Remember, a quadratic equation is any equation with degree of 2. The highest exponent is 2. And there are really 4 ways you can solve a quadratic equation. If you have a polynomial that factors, you can use the shortcut factor method. If you have a polynomial that has a perfect square component, you can use the square root method. But what if neither of those conditions is there? Then you have to resort to something like completing the square or the quadratic formula. Let's look at completing the square first. With completing the square, we are going to force a normal polynomial to become a perfect square quantity so that I can resort to using the square root method. So the first thing we need to do is find out what term should be added to the binomial part of the problem to make it a perfect square. Let me examine and show you this. Look at the term in front of the x. What you will do is take that term, that coefficient in front of the x, and you will always divide that by 2. That gives me -3. And you square that -3. So -3 times -3 is +9. So what needs to be added in? A +9. Now, once I add that in, let me go back and look at what I have. I have a perfect square trinomial. I can factor this perfect square trinomial. It is x times x, which gives me x squared. And what number would multiply to give me 9 and add to give me 6? That's right, it's +3. Whoops. So I'll just put in here my +3 and my +3. Now you may find it more helpful for this procedure to just write it as x + 3 squared. Now, let's do it a little quicker. I will take the -10. Remember, you always divide by 2 for this process to get a -5. And then you will take -5 and square it. That gives me 25. So +25 is what I must add to that binomial to make it a perfect square trinomial. Then I will factor it. It will be something perfect squared. Look at the first term. That's x squared. What times what? That's right, it'd be x. Look at the last term. That's your 25. Now, what had we squared to get that 25? Right up here in my notes, I see it's -5. So that would be the quantity, the factors. Now, notice each of these factors, for example A and example B, are perfect squares now. Now let's use this process with the entire problem. Okay, let's complete the square for this trinomial. I will first take the 4. Excuse me. I will take that 4 in front of the x and go over here to the side and do my process. So I'm going to say 4 divided by 2 is equal to 2. And then what do we do to the 2? You square it. 2 squared is equal to 4. Now, that means this binomial needs a +4. So I have x squared plus 4x plus 4. Now, what should I do with that -1 that's there? Move him over. If there's a constant outside of the perfect square part, move it over. So it becomes a +1. Now, did you notice when I put that 4 in there to make it become a perfect square trinomial, since I have an equal sign, what I do to one side of the equation, I must do to the other to keep it balanced. So I have to put that +4 actually on both sides when you're working the solving of the equation. Now I will factor the trinomial, and it would be x plus 2. X times x is the x squared. 2 times 2 gave me that 4. On the other side, 1 plus 4 is 5. Now I can use the square root method. So I take the square root of both sides. So that would be x plus 2 is equal to plus minus square root 5. Don't forget, you need that plus or minus when you take the square root. Last step is to move the 2 over. So x is equal to negative 2 plus minus square root 5. And that does represent the two answers of this quadratic equation. Now, let's recap. What you'll need to do is move the constant number, that was our negative 1, move the constant number over. Then you will divide by 2 and square the x coefficient. And last but not least, you will factor, because it will be a perfect square, and take the square root to solve. And don't forget that plus or minus. Now this whole process, some students don't like the process. Now some people do like the process, but some people just don't. So through the years and ages of mathematics, mathematicians from 2000 BC up to present have started noticing patterns. Mathematicians notice the pattern. If you're going to do these same steps over and over and over, could there not be a formula that was devised from these steps? Yes, there could be. So what we are now going to look at is the quadratic formula. The quadratic formula was actually formed, and it gives us the two solutions. You'll notice the formula itself is a pretty large formula. Now, you're not going to have to memorize that for our purposes. You can just use your notes to apply this formula. This formula came down through the ages of mathematics from several mathematicians. The first mathematician who ever described the quadratic formula, but he used words, he didn't put it in formula, that was way back in 628 AD. And his name was Brahmagupta. He was an Indian mathematician. Then, long time there, you're looking at like 900 years, or so, another mathematician came in and said, you know, instead of us just keeping using words, let me go ahead and put it into a regular formula that people can quickly look at. And the gentleman who did that was Simon Stevin. And Simon Stevin put it in the format of the formula we know today way back in 1594. However, he did not publish that widely. So a name that we've studied before, René Descartes, he was the young French mathematician who gave us the system that we graph shapes and ordered pairs on with the x and y axes. He actually published the formula in his publication in the year 1637. And that is the formula we're still using today. Now, here's how the formula will work. You simply take the coefficient of the x squared and the x and the constant. So you do need the trinomial, or you need your equation equal to 0. So make sure that it is equal to 0. Then the first number is the a. So the 2 is my a. Just drop off the x squared. The second number here is my b. Don't use the x, just the 2, the coefficient. And the third number that I will need for this formula is a negative 1. Notice I used negative 1 because it had a subtraction sign. Now I'm going to substitute those three numbers into this formula. So x equals negative b would be negative of 2 plus minus square root. B squared is 2 squared minus 4 times the a number times the c number, all over 2 times the a number. So everywhere there's an A in the formula, you substitute in a 2. Everywhere there's a B in this formula, I have to substitute in 2 again. Where there's a C in this formula, I substitute in the -1. Now, I need to simplify. -2 plus minus, on the bottom, 2 times 2 is 4. Under the radical, 2 squared is 4. And you see these three numbers in the formula? That -4ac, those will always be multiplied together. So -4 times +2 times -1. That's going to give me a +8, which is -2 plus minus square root 12 over 4. Now 12 needs to be simplified. If you think about it, 12 is 4 times 3. So I take the square root of both of those parts and replace it. So it's -2 plus minus, okay, the square root of 4 is 2, and I put the square root of 3 behind it, and that's all over 4. Now all I have to do is separate it and reduce. So I'm going to put -2 over the 4 plus minus 2 square root of 3 over the 4. Now what is 2 over 4? It's 1/2. Whew, final answer. -1/2 plus or minus 1/2 again and square root of 3. Now over here at the end, you don't have to put that 1 with that square root of 3. You could just let that be understood. But this would give you your two solutions. Aren't you glad we have a formula? Let's look at another one. In this example, my A is a 1. Anytime the number coefficient is missing, go ahead and use a 1. So A is 1, B is -2, and C is +2. Let's put it in the formula. Remember, it's -b plus minus square root b squared minus 4ac all over 2a. That's the formula. So I'm going to have negative of -2 plus minus -2 squared minus 4 times 1 times 2 all over 2 times 1. All right, let's simplify. In the front, negative of a negative. Anytime you have negative of a negative, that is going to indeed be a positive. On the bottom of the fraction, 2 times 1 is just 2. Bring over plus minus. Underneath the square root radical symbol, -2 squared is 4. And remember I said take these last three numbers and multiply those together. Well, -4 times 1 times 2 is a -8. That will now give me 2 plus minus square root -4 over 2. Now, do you remember us studying imaginary numbers with the letter I? Okay, that's what's going to happen here, because we can simplify square root of -4. That is a 2i. So go ahead and simplify that to 2i. You always will need to separate your final answer. So I'll take the first term over the denominator, the last term over the denominator, and what's 2 over 2? You're right, it's 1. So that will give me 1 plus or minus 1i. Now when 1's a coefficient, you don't have to write it, and that does represent our two answers. So you can get radical answers, you can get imaginary, complex answers. One more example to show you what happens when you don't have numbers for A, B, and C. In this example C, I notice I'll have to use a 1 as my x squared number. So that means A is 1. B is always the x coefficient, so B is -5. However, notice that there's no third component for C. If you have any number at all missing, the B or the C, go ahead and use a 0 for that missing number because it is absent. Now let's use the formula again. -b plus minus square root b squared minus 4 times a times c all over 2a. That's that long formula. Now let's substitute in. Negative b here will be negative of negative 5 plus minus the square root of negative 5 squared minus 4 times 1 times 0 all over 2 times 1. Now let's simplify. Remember, negative negative makes that a positive, so that's a positive 5 on top in front of the plus minus. In the bottom of the fraction, 2 times 1 is just 2. Now let's simplify under the square root radical symbol. Negative 5 squared is a positive 25. And remember, these last three numbers get multiplied together. The cool thing is, when you multiply negative 4 times 1 times 0, you just get 0. And 25 minus 0 is the same thing as 25. Okay, now this will simplify. What is the square root of 25? You're right, it's 5. So I have 5 plus or minus 5 all over 2. Now, since we did not have a radical and we did not have an I term, instead of separating this at the end, let's go ahead and combine the like terms, because on top here I have two 5s. I can combine those. If I combine the 5 plus 5 over the 2, 5 plus 5 is 10, and 10 over 2 is a whole number. So we get an ordinary looking answer of 5. If I combine my like terms on top with that subtraction sign, excuse me, I was getting ahead of myself there. 5 minus 5 is 0 on top, and I bring the 2 over, 0 over 2 is equal to 0. So my two answers here are positive 5 and 0. Hope this shows you a little bit more about the history of the quadratic functions and the quadratic formula. Good luck!